80% of the value of the S&P 500 is based on intangible value, intellectual property. This represents a seismic shift from the tangible goods of manufacturing to the intangible goods of brand. It took about 100 years for the concepts first introduced at the Portsmouth Block Mill to reach the sophistication of Ford in Dearborn. We are at the very early stages of evolving the next assembly line, the project, to an efficiency on par with the tangible assemblage of the last century. Manufacturing aims for 6 sigma, or 1 failure per 1 million opportunities. However, projects, the new assembly line, fail at least 30% of the time, which is 2 sigma. It seems we have a ways to go. However, a little bit of economic math really helps focus the importance of getting projects right. For instance, U.S. GDP in 2010 was $14.7 trillion. Our intangible economy, 80% of that GDP, equals $11.47 trillion. From there, if you look at the 30% project waste, it's $3.52 trillion. Our project waste alone would place 4th in GDP ahead of Germany. Okay, let's look more closely at the concept of project. A project is instantiated by a goal. Let's do something. It is then bounded by when the goal is needed. Let's do something by April. It is then further bounded by who is available to accomplish the goal. Who can help me do something by April? Okay, so the CEO says, we have to do this goal by this time with these resources. The goal is in place and defines the operating boundaries for the team. Theoretically, the team is staffed with the most appropriate members that have availability for the time period. In old school project management, this is thought of as the 3 legs of a project: scope, schedule, and resources. The old project manager joke is that you can change 2 at any time, but the 3rd leg will be unbounded and directly equal to the changes in the other 2 legs. Thus, the goal divided by time equals the required resources. We break the goal down into things we can do over the time period, which results in the need of so many resources. Change the resources and the time period changes, or the goal has to be adjusted. Change the goal, well, the time period has to change, or the number of resources consumed has to change. Pick 2, and you'll see what happens to the 3rd. Logical, yes, but why is this so? In any social grouping over time, the group participants tend to develop routines of actions. We call it process. Process is a very beautiful construct. Simply, process is things acting on things in a sequence. Sarah documents requirements. Jim writes code. George tests software. We all know that documenting takes time. So too does the writing of for loops in software. George likes to mountain bike every day, so he only works 8 hours. As can be seen, the very nature of process means that process controls 2 of a project's legs: time and resources. In a business, only the goal is a free variable. Each action in a process, document, write, test, etc., whether formally documented or not, takes a range of time. That time range has many determinants, and each business may have differing durations from others, but the range of time is not unbounded. Resources are bounded as well. Sadly, we just have so many. However, each resource has a range of times for each process action. We know that Brad writes code better than Doug. So for each process action, we have tolerances for time and throughput that varies by resource, time of year, and the general environment. No wonder projects are at 2 sigma. The goal that germinates the project causes the project to consume some processes for the time period allotted by the CEO. In effect, a project is a collection of processes over time. Isn't that similar to an assembly line? An assembly line has stations that consume time and resources to add some additional value to finish a tangible good. The goal is a monetized tangible good. Manufacturers measure the consumption of resources, station times, and consumer uptake for each good. Manufacturers are constantly tweaking the parameters to optimize the value of the finished good. They are so good at optimization that most manufacturers have less than 10 defects for every million defect opportunities, with some at less than 4 defects per million. Manufacturers understand their assembly lines and their tolerances in great detail. Okay then, the project is an intangible goods assembly line that consume processes, which in turn consume time and resources. Input a goal and the project is up and running. Sadly, most project factories have 300,000 defects per 1 million defect opportunities. Why? Because we are not measuring the assembly line stations process. We absolutely must start measuring the durations and resource consumption of each process action. Until then, our goal, divided by time, will equal resources and remain unsolved for most projects, resulting in failure. At Métier, we have over 14 years of experience in solving the goal divided by time equaling resources problem. Contact us to see how we can help you solve this problem and work forward.